So this is the introduction to physics class. So we'll start from the syllabus. So we'll have total 28 class, basically covering all the topics in AP Physics 1 requirement. So mainly, see if you look at this screen, from 1 to 24, that's all mechanics. So AP Physics 1, so it's basically mainly about mechanics. Then after that, we have a little bit of wave and electricity and circuit. So that will be covered in the last 4 class. Today, I will just do some introduction and basic stuff. After this class, I will invite all of you to my Canvas class. So everyone needs to sign up. So please do not draw anything on my screen, okay? Let me see how I disable. Okay. So whoever draw on my screen, please remove it. Let me see how do I remove these things. Okay. Do not annotate my screen, okay? Okay, let's go on. Everybody know everything starts from math, but math is not a science, okay? So the basic, the most old science, or the parent of all science, is actually physics. So math, we have physics after math, but everything else are getting out from physics. So astronomy is part of physics. Chemistry is derived from physics. Then biology is actually derived from chemistry. And there's also biochemistry. Medicine is pretty late in this tree. And we have geology, geochemistry. Those are derived from chemistry. But physics, so anyone know what is physics? You can type your answer in the chat. I'll read it. So study of motion, that's just one part. Study of energy. Yeah, I think this one is more accurate. This is how we understand the world around us. So at the beginning, the most thing we find is, okay, we got actually is astronomy. So we find there's the sun, there's the moon, and there's stars that's circling around us, right? So physics is the study of the physical world around us. So that's why it's a parent of all science, because all science is actually study the world around us. But it got the branches because we want to have more detailed branches. So we study when the molecule changes, we call it the chemistry. Right now, physics is only limited to basically when we don't have molecular change. Okay. So now, so how do we study a science? So we call this a scientific method. So first of all, you observation, you have the observation, you look around, you observe the world around you, right? Then you propose something. So the second is you ask questions, why it's working this way. So the simple example is, people see, okay, the sun is circling around us, the moon is circling around us, the Mars is also circling around us. So from this observation, do you have a hypothesis or explanation? Think about if you were living like 5,000 years ago and you saw this happening, what's your hypothesis? So the simplest hypothesis would be, okay, we are the center of the world, right? Everything, all the planets is circling around us. The sun or star, we don't know the difference, but they are just circling around us. That's a good hypothesis. Then we make the prediction. Okay, we think they are moving around us at constant speed. So we can predict after a year or after a day, everything come back to the same location, things like that. So how people find out the Earth center is actually not the right theory. The theory of Earth, its center of the universe, is wrong. Okay, I'll show you something. So when people have more detailed observation, will have more data, you'll find out it's kind of weird to have this Earth-centered theory, okay? I will have this posted on Canvas, so you can play with it if you want later. But right now, let me click it. And I show you this. Okay, at the beginning, you may not know what I'm doing, so I'll just remove some of the curves. Okay, right now, there are only two curves. We're assuming the center is the sun, okay? And the smaller circle is the orbit of the Earth, which has a radius of 15. And the bigger circle is the radius of the Mars, which has a radius of 22.8. So this is just by ratio, it's not a kilometer, okay? Okay, let me try to run it. You can see right now, let me remove the other things we don't need. Okay, these two we don't need. So if you look at here, the R equals 1.88. This is the ratio of the period of Earth's orbit, the Mars orbit to the Earth orbit. That means when the Mars making a whole circle, the Earth make 1.88 of circle. Earth's year is 365 days, right? And the Mars year is 1.88 times the Earth year. I saw a question about Canvas. Canvas is an education management system. So you will get all the class materials from Canvas and you submit your homework on the Canvas and you got graded over there and you communicate with me in Canvas. So this view is like when you are standing on the sun, okay, because sun is the center of this thing. So if you are on the sun, you'll see the Earth, Mars, moving around like this, right? The Canvas link will be emailed after this class. Okay. So this is the simple, but this is you observe everything on the sun, but we are living on Earth. So we are living in this smaller circle. So in your observation on Earth, do you see something like this? No. Okay, if I add these lines, I go back. So at the beginning, see, these two lines are always have the same direction and length. So if you are in the center and live on Earth, you will see the Mars is actually moving in a different way. If I add these lines back, let's try again. See, if you are the person observing from Earth, you will see the Mars has an orbit like this. I remove the two small circles and the Mars circle. I remove this one and these two dots. No. The dot and this dot. So the origin right now is representing the Earth. So if you are looking, if you are observing the Mars from Earth, this is actually the orbit. You can see how we get this. That's calculated from the distance from the Earth to the Mars and the direction. So I'll show you these circles again. See, small circle is the Earth orbit. Bigger circle is the Mars orbit. So for these two circles, the sun is at the origin. But if we change the origin to the Earth, we'll see the Mars circle is actually the bigger one. So this is just when the Earth making two rounds. Here, look at this number. The 4 pi means the Earth making two rounds. So I'll make it more. So if I make it 6 pi, 8 pi, 4 years, 10 pi, that's 5 years. So if I make 100 pi, you'll see actually that's, if you observe for 100 years, you'll see the Mars will circling around you in this pattern, you know, following around different tracks. Sometimes very near to us, sometimes it's very far away from us. But after 100 years, they go back to almost the same location as before. So you can have this link. I think somebody already posted this link on the chat. You can play with it when you have time, when you go home. And not go home, stay home after class. Okay, so now let's go back to the hypothesis. So if in our simple observation, if we think Earth is the center of the universe and Mars is circling around us, what do you think if you actually recorded the distance of the Mars from us and the direction of the Mars from us and get that complicated orbit, will you still think it's a good theory to have Earth at the center? So people actually observe for different planets, they have a different complicated orbit, right? That makes the whole theory, Earth-centered theory, too complicated. So people think if the sun is the center, and every planet just need to make simple round orbits around the sun, then we actually observe the same result on Earth. Okay, of course it's not universe. Right now the universe is the solar system. Let's talk about everything in the solar system. So compare these two theories, Earth center and sun center in the solar system. Which one you think is the simpler theory and explain more clearly? It's definitely the sun, right? Because in the sun center, every planet is just make simple, constant velocity circular motion around the sun. But if Earth is center, every planet will make very complicated orbits. Okay. So now let's go to the basics of physics. So when we observe the world around us, the first thing we want to do and can do is do the measurement. So how do we make a measure? So for example, if you are a person, okay, you're standing here, and I give you a meter stick. With no mark. So what you got is the meter stick is just 1 meter long, but there's no mark on the meter stick. So when you use this meter stick to measure yourself, are you able to tell your height? You may guess, okay, this meter stick, if I align the bottom to my feet, okay, the top to my chest, okay, that's 1 meter, right? Now, how about this part, the top to here? It's less than the meter stick. It's about maybe a little less than half, right? I cannot tell because there's no mark on the meter stick. I'll say, okay, maybe a little less than half is 1.4 meter for me, right? So depending on the equipment you use, you cannot tell how accurate, you cannot tell very accurately how tall you are because the meter stick is so long and human eyes cannot check very accurate divider. Maybe you can divide it into 4/4. I think 1/8 will be hard to think. So that would be the number of your measurements. But if you have a different meter stick, you have a meter stick with a centimeter mark, which means you have it divided into 100 small, very small marks. In this way, if you, if you make if you mark yourself on the wall and use a meter stick to measure, you can easily measure to a very accurate result of 1.44 centimeter. And maybe you can have more because it's a centimeter mark. And if this is a centimeter and your mark is over here, okay, you can see, okay, it's about half. So you can have 1.445 centimeters. You can see the equipment actually will make a big difference. So here we call the equipment, the accuracy in the equipment as the precision. And the accuracy itself, it means how close the measurement result is to the actual result. So the difference between a precision. So precision is describe the equipment, basically. So this meter, if the meter stick with no mark is 1, and the meter stick with centimeter mark is 2, then one will have a precision of 1 meter, right? The 2 will have precision of 1 centimeter. So remember, the precision is about describing how accurate your equipment can go. And accuracy is talk about the result. So one time you got 1.4 meter. The other time you got 1.445. It's not centimeter, sorry. It's a meter again. So if your actual height is 1.4456, right? Forever, because there will be an actual result of your height. So the 1.4 will be about, when we say 1.4 meters, that means, okay, we are not sure how, basically we are plus or minus the last digit as 1. So 1.4 meter can be 1.3 to 1.5 meter. And this means 1.444 to 1.446 meter. Okay. So the accuracy of this measurement is 0.1 meter, and the accuracy of this is 1.445 plus minus 0.001 meter. So this accuracy is 100 times better than the first one. So that's the difference between the definition of precision and accuracy. Okay. Now, so how do we estimate uncertainty? Actually, I already talked about it. So in physics, we don't want to always write in this format. Okay, a number plus minus something is too hard. It takes too much space. So we basically we're seeing the last digit have a different have an uncertainty of 1 around that last digit. Okay. So if I have a, in physics, everything is different from math. For math, a number is just a number, right? But physics, number must have unit. Okay, so if you're saying in math, you say, okay, 2. So in physics, 2 means what? Nobody knows what is 2. So you are talking about 2 meters or 2 seconds, right? Or 2 centimeters. So using a different unit, it means very different thing in physics. And in physics, because a number also gives you the accuracy of this number. So when you say, okay, 2 meters, which means it's 1 to 3 meters, because the last digit will means there's a 1 of uncertainty. But if you say 2.0 meters, oh, that means a difference. It's 1.9 to 2.1 meters. Okay. Okay. We also have the percentage uncertainty, which is for this one, because the inaccuracy is 1 meter, the total is 2 meters. So this is about 50% of uncertainty. How about this one? Who can tell me what the percentage certainty for 2.0 meter? You can type your answer. Let me check how many of you get it. So 2.0 meter means the difference in the last digit is 0.1 meter, right? So that's the uncertainty. Convert to percentage, 0.1 divided by 2.0, which is a 5% uncertainty. Okay, most of you got it. That's good. Okay.
What?
Aaron is an 8. Oh, so
I have a wrong button click. Okay, so that's the certainty. Now let's go back to the next topic, which is called a significant figures. Okay, significant figures. So we talk about 2 meter, 2.0 meter. So we're just counting how many digits we have. From the first non-zero, okay, from first non-zero digit to last digit. So for 2 meter, we have 1 significant digit. For 2.0 meter, we have 2 significant digits, okay? How about this? 0050 meter. How many significant digits? 2, yes, because the 0 in front doesn't count. How about 0.0050? How many significant digits? Also 2. Because in physics, we can change units, okay? 0.0050 meter is exactly equal to 0.50 centimeter, right? See, they must have the same significant digits. Or you can say it's 5.0 millimeter. So because the front zero can be removed by changing units, but the later zero after this zero. So these have a 2 significant digits. Sometimes, you know, this something will make you confused, okay? Like if I say 1.5 kilometer, right? How many significant digits in there? 2. But if you convert to meter, it'll say 1,500 meter, which give us 4 significant digits. So which make a confusion. This is 2, this is 4, which one is right? So in this kind of confusion, because both are right, we want to make sure nobody get it wrong, okay? So to remove the confusion, we use scientific notation, okay? So what is scientific notation? For any number, we use a format like this. A number, for this one, we'll say 1.5 times 10 to the power of 3. So the scientific notation requires this number to be between 1 and 10. Okay, so we'll need to write something between 1 and 10. Then we times a power of 10. Yes, 10 is exclusive. So when you have 10, you write as 1. So for between 1 and 10, we'll write like this. 1 is inclusive 10. You use a square bracket to means, and you use a parenthesis to means exclusive. So that's a number between 1 and 10. Let's do a little practice. Okay, so let's write 0, 0. Okay, write this in the scientific notation. So the class will end in 1 hour. but we'll have a break in 10 minutes. Okay, see, this number, if we want to make it between 1 to 10, divide by 10 to the power of, you move the dot 1, 2, 4, 5. So you need to divide by 10 to 5, 1.23, right? So 123,000 will equal to 1.23 times 10 to the power of 5. Okay, another practice, 0.000002300. How do you write this in scientific notation?
Hi.
Hello.
So please mute your microphone, okay? Okay, we need to make sure we still have the original number of significant digits. So how many significant digits in this number? The purpose of scientific notation is to make sure we have the correct significant digit. So we have 4 significant digits. So we need to make sure we still have 4 after we write it in scientific notation. So it will be 2.300 times 10 to the power of what? When we count to the right, 1, 2, 3, 4, 5, 6, 7. So it's -7. Okay. We need to keep the zeros so we have the correct number of significant digits. All right. So now we learn how to do the scientific notation. Now we need to find out how do we keep the right amount of significant figures, digits, when you do the addition, subtraction, multiplication, and the functions, okay? You don't lose any significant digits. When you convert to scientific notation, we remove the confusion we talk about here, like 1.5 kilometers equal to 1,500 meters. So if you just look at these two numbers, they have different different number of significant digits. To remove the confusion, we'll write this 1.5 as 1.5, this 1,500 as 1.5 times 10 to the 3 power 3. So this is kilometer, this is meter. Both will have 2 significant digits. Okay, now if we are adding 2 digits, if we are adding 2 numbers, how do we keep the right amount of significant digits? As we talk about significant digits, why we want to have significant digits? The purpose of significant digits to tell you is to tell uncertainty, right? Uncertainty. So when we write 1.5, which means it's plus minus 0.1. If we write 1.500, which means the uncertainty is 0.001. But when we do addition, okay, one simple example, 1.5 meter plus 0.0001 meter should be what? So in mass, of course, you write 1.5001. But that's for math people. Now you guys become physics people. Physics people, everything means accuracy. Okay, every digit means accuracy. So 1.5 means what? We have something between 1.4 meter to 1.6 meter. Okay, now this 0.0001 meter, okay, we don't care anymore because we are in this range and you're adding this much. This is just much smaller than the uncertainty of this number. So the answer should be adding this plus that. We are still between 1.4 to 1.6. So the answer should be just 1.5 meters. So this is for addition. Okay, let's do one more example. Okay, I have a 2.0 second, 2.0 second, 2.0 second plus 5.2 millisecond. What is it? Yeah, the uncertainty definitely add up, but let me see why. Let me explain why it's like that. So in mass, of course, it's basically 2.052 meter second, right? That's for mass. We keep every digit. But in physics, every number is just not a number, it's a range. So this is 1.9. We'll just write something like this. Okay, that's right. 1.9 to 2.1, right? Plus 0.0051 to 0.0053. So what's the new range? If we do this, we can see the range. The new range is the smallest possible is 1.9051. We add the small bound, the lower bound. And we also add the higher bound, 2.1053. So this is the new range after this addition. Okay, but for this range, how do we just write it as a number with just right amount of significant digits? It's 2.0, because 2.0 just means basically this range, 1.9 to 2.1. So this basically are same range. So uncertainty means we make a measurement, but because in the physical world, there's no absolute right answer. So we measure something at a 2.0 meter, which means we are not sure it's not exactly 2.0 meter. It can be 1.9 meter, as low as 1.9 meter, and it can be as high as 2.1 meter. The uncertainty will be the difference of the smallest and the maximum to the measured result. So the uncertainty is 0.1 meter. And the percentage uncertainty, as we already calculated, will be 5%. So if you are not catching up what I'm talking about, you can write out why you are not understanding. See, is there any gap I can help catch up? Okay, it's 45 minutes. We'll take a 5 minutes break, okay? All right. Okay, let's, I saw some questions. One is about the 123000. If we are sure this has 6 significant digits, we should write it as 1.23000. And we're sure we need to write that. But sometimes we have a lot of zeros. It's not because we are as accurate as the last digits. We just have to add zeros to make sure we are that big. Like when you say 1 million meters, a lot of times you are not as accurate as 1 meter, right? You may be just as accurate as to these digits. Then in that case, you just write 1.0 times 10 to the 6th meter. Okay. The other question about the range, right? Why 1.9051 to 2.1053? We can write it as 1.9 to 2.1. That's because we have 1 meter, we have 0.1 meter of uncertainty. Which means we do not care about more digits behind anymore. We don't want to write uncertainty as 0.105. Compared to these two, physically, it makes no difference. Okay? For uncertainty, usually we only have 1 6 digit, okay? We don't need more significant digits for an uncertainty part of the number. Okay, let's continue to do a multiplication part now. So let's make a very simple example. If we want to find an area of some rectangle, and this side is 1.9, this side is 2.3. Fine, let's see, meter, find the area. So you guys will get a calculator like this and type in 1.9 times 2.3. It's 4.37, right? Okay, that's a mathematical answer. So 4.37 is the math answer. In physics, what do? We basically can do, because 1.9 means 1.8 to 2.0, right? 2.3 means we have 2.2 to 2.4. Okay, so let's calculate the lower bound and the higher bound. Because that basically means we have a smaller rectangle and a bigger rectangle. And we want to find the area of the smaller one and the big one. So if you use your calculator, it's 3.96 to 4.8. So now, what do you think your answer should be? Do you want to have answer of 4.37 is 3 digits, or you want to have 4.4, which is 2 digits. So this basically means 4.0 to 4.8, which means 4.4 plus minus 0.4. See, even we write 4.4, which means 4.3 to 4.5. This is still more accurate than the real result. But in physics, we'll just live with it. We'll just keep 4.4. So we'll say S equals A times B equals 1.9 times 2.3 equals 4.4 meters squared. So a common rule for multiplication, okay? Multiplication. Keep the least number of significant digits. So we have this one, we have 2, this one we have 2. So in the answer, we'll have 2. How about we have 2 and 3? Why we have this rule? This rule comes from actually the percentage uncertainty. When you have 2 digits, your uncertainty is about 1%, right? Then the answer must have around the 1% of uncertainty, which means you can only keep 2 digits. How about another? Let's try 3.5 times 2.423 meter. So what should the answer be? In your homework, I don't want to see a number like this, okay? So in your homework, I want to see 8.5 meters squared, because these are 2 digits, these are 4 digits. So the answer will only keep 2 digits. Okay. Now let's go to a different. When we have a function, we talk about multiplication, plus minus, multiply, division. Okay, division has the same rule. How about when you have cosine or sine? So, okay, let's say a 29 degree. This is 2 significant digits. Then cosine. Okay, when we talk about angles, we use a Greek letter. So usually we call alpha, beta, or gamma, or theta. Angle, we usually use theta. So I think some of you will be not familiar with Greek letter. If you're not familiar with Greek letter, can you type 1 in the chat? Okay, so in physics, we use variables, okay? That's a common routine of variable use. So for example, we use V as velocity, right? We use A as acceleration. I will use X as distance. I think everybody can write into chat. I saw you in the chat. Please do not turn on your microphone if you are not asking a question. I think there's two me. I saw two me here. Anyway, hold a second. Let me check why there are two me in this class. Okay, looks like the problem solved. Let me kick the other one from, kick other me out of my room. Okay, so we use variables in the physics, velocity as V, acceleration as A, distance use X, and the angles we usually use theta, which is a Greek letter. So a Greek letter, if you must have seen some, those are examples of Greek letters. Alpha, beta, gamma, theta. Those four are the most commonly used. So this is called alpha. This is called beta. This is called gamma. And this is called theta. So basically, if you know these four Greek letters, you are good in this class. We don't use other Greek letter much. Mostly these four. Maybe there's a delta, but we can learn that when we encounter it. Okay, so usually if you see an angle, you can name it the theta. So if you have an angle of 29 degrees, use your calculator, calculate what is cosine theta. I see a question. This is the AP Physics 1 class. So I think someone said I mute everybody's chat. Let me see if I can allow it. And you check. Okay, I see people you should be able to post in the chat. Okay. So there's a trick in the scientific calculator. So did you see this DG? This means degree. So when you do any of the sine, cosine, make sure your calculator showing a DG. Okay. So if you click on the DG, you see radian and the grad. So there's 3 different units for the angle, but we are most time right now we're using degrees. Okay, because if you use radian, you have a totally different answer. So for degree, if you do 29 and do a cosine, you got 0.8746. I think that's right, 0.875. 0.875. So how many digits we should keep? We are not sure. So what do we do? Because 29 means it's 28 or 30. So let's try a 28. Cosine of 28 is 0.8829. So we have a 0.8829 or 3. Then you can try 30. So you do a cosine 30, you got 0.866. So you have 0.866. Okay, see, it range from 0.86 to 0.88. So I just write 0.87 as the answer, which about to match the accuracy of 29 degrees. So I don't want to see an answer of 0.875. This is wrong because too accurate, which means the answer is between 0.874 to 0.876, which is definitely too accurate. Of course, I don't want to see more numbers like this. That's much, much worse. Okay. So today's homework, we'll have some about the calculation of, I want the answer. The answer should be in the right amount of significant unit. So the class will end in 20 minutes. Okay. Homework will be posted on Canvas, and I'll send a link to invite you to my class after this online class, after this video class. So the answer is 0.87. Okay, so we finished this part of significant figures. And let's see. Okay, let's go on to talk about unit. So 0.88 and 0.87 are both correct. So in physics, we usually grade the answer with some range. So you can answer 0.87, 0.88, 0.86. They're okay. They're both all right. Okay, we have, in physics, every number need to go with a unit, right? And we have a lot of, in the whole world, except UK and US, all the other part of the world use the MKS system. They don't use our English system. Zero still need a unit. You need to make sure it's talking about time or distance or anything. Okay, so in the world we use MKS system. So what is MKS system? MKS system. So this is a 3 unit in. One is for length, one is for mass, and one is for time. So MKS system is a subset of a metric system. Metric has more units. MKS is just about length, mass, and time. We're not talking about any electricity or any, magnetic field, anything like that. So length, we use meter. Mass, we use kilogram. And time, we use second. So if you are saying I'm using MKS system, then you don't need a unit because all the units are perfectly defined. So using our MKS system, remove a lot of conversion. So you can say I'm 1.8 tall, which means you're 1.8 meters tall. You can say my velocity is 1, which means your velocity is 1 meter per second. So that's the benefit of MKS system. So for mechanics, every unit can be a combination of these 3, okay? Let's try it. How about velocity? So velocity, if you don't know what is velocity, we'll talk about later, but velocity is meter per second, okay? And how about others? Your weight, when you say, not weight, Newton, the force. Force is actually pretty complicated. It's a kilogram times meter per divided by second square. This is also called Newton. This is a unit for force, but every unit in the MKS system can be converted into combination of these 3, length, mass, and time. Okay. So let's learn some let's learn some how to convert units. Okay, unit conversion. So for example, if we know in US, we always use the miles for distance, right? Mile. So what is 1 mile in meter? 1 mile is how many meters? if you know it, you can type it around 1600, right? So, but it's not that accurate. For that accurate, it should be 1609. But because we have writing 1 mile, we don't want to write too accurate here. So we just write 1.6 times 10 to the power of 3 meters. Now, 1 hour is 60 minutes, right? We don't know that. We know it's 3,600 seconds. Now, let's see how to convert your speed. You know, when you're driving, you see a speed limit, right? Speed limit. You know, in US, the speed limit is miles per hour. This is the US. But in Canada, if you live in Canada, let's write Canada, Canada. You use kilometer per hour. So how do you convert? So if we have a speed limit of 45 miles per hour, how do we convert it to kilometer per hour? So to do the conversion, you know, the simple rule is you time a value of 1. So 1 equals what? 1 mile, 1.6 kilometer, right? Or it can be 1.6 kilometer divided by 1 mile. So 1 mile is 1.6 kilometer. 1.6 kilometer is 1 mile, so they both equal to 1. So when you want to convert something like 45 mile hour, so you want to time of 1, but you need to choose. Do you want to time this one or this one? 1 or 2? Because here you can see the mile is the numerator, so you want to cancel the mile. Then you can have a kilometer left. So the 1 we'll write is 1.6 kilometer and 1 mile. Now we remove the 1. You can see there's a 1 mile here, there's 1 mile here, and they're canceled. So you got 45 times 1.6. Then the unit becomes kilometer per hour. Okay. So let's do a little more complicated one. So we know the fastest human speed, right? Like, you know, the 100-meter dash. If you can run under 10 seconds, you are like the super athlete in the world already. So about 10 meters per second, because 10 seconds you can run 100 meters. So that's the fastest human speed. So let's convert this into miles per hour. So let's compare the car speed we already know. So we drive usually we drive 35 miles per hour on local road. Is this faster or much faster than the human in 100-meter dash. So now we have the beginning 1 meter per second, 10 meter per second. So let's just write it as 10 meter 1 second. Now we have units. We have 1. For miles and meter, we have 3,600, no, 1609 meter 1 mile. We can also write upside down, so we just need to make sure which one we want to use. From second to hour, we have 1 equals 1 hour, 3,600 second, or we can write 3,600 second, 1 hour. So we need to choose 1, 2, 3, 4. Which one we want to time here? Okay, anyone can tell me which one we want to time use to trail here, so it can be canceled. So 2 and 4, okay, people say 2 and 4, let's see if it's right. So it'll be 10 meter 1 second. 2 is 1 mile, 1609 meter. So we choose 2 because the meter is the denominator, and meter here is numerator, so they can be canceled. Then 4, we have 3,600 second. Here the second is the numerator, and here second is in the denominator, and this 1 hour. So now we can finish up. We only left is miles per hour. So we got 36,000 divided by 1609 meter miles per hour. So who can give me the answer? $36.
So who can give me the answer?
Okay, calculator give us 22.37. But look at the 10 here, we have 2 significant digits, so we don't need that. They become 22 miles per hour. Okay, see, compared to our car driving, the fastest human looks pretty slow, right? Who knows the fastest animal? How fast can they run?
Your mom.
For land animal, I think it's cheetah, right? Cheetah can get to 70 miles. $70 miles per hour. So how many meters per second is that? Because we have a 10 meters per second equals 22, so we just need to divide by 22 now. So it's 70 divided by 22. If we use 70 divided by 22, we got, not 22, 2.2. So it's about 32. So 32 meters per second. Now 3.2, be careful about, this is my fault, it's 2.2 because this is 10 meters and 22. So we need to basically times 10 meters per second. We have 22 miles per hour, 10 meters per second. So this is the unit, this is 1. So this can cancel. We got 700 divided by 22, which is 32 miles, 32 meters per second. Okay, it's about time. Thank you for coming to this class.